Good morning, everybody. Today I'm going to do a presentation on Groovy and Grails. Um, okay, so Groovy is a dynamic language based in Java. It's just that Groovy is more concise, and it's just like Java. Everything that is valid in Java, any Java code is valid in Groovy. So you could just write Java code and then build it as a Groovy program, and then you could run it on JVM. So, except it has powerful features like closures and builders, and then it is easy to read, and then there's fast, it's not a steep learning curve. And today for the demo, I have Groovy Grails tool suite. It is an Eclipse-based IDE, and let's see how we can do a couple Groovy programs. So I could just go and create a new Groovy project, and then do a Groovy project right there, and then name it and then I could go and create a new Groovy file. Call it let's create a Java file. So let me delete that. That's a Java. Groovy class.
Groovy is a language, Grails is a framework.
So Grails is a framework that would for a Groovy-based project.
Right.
Yeah. So and then in here we could do just like static void main like in Java, and we could just say hello and save it and then run it. I run it as a script, and then it prints out that hello world. So if we notice, we don't use a public identifier. So everything in Groovy is public. So there is no package scope. If you don't put anything, it's not that it is only package visible. So it is by default public. And if you want package scope applied to it, so you annotate it with package scope. So, and in Groovy, it is not strongly typed, so you don't have to say it is a string or an integer or a long. So all you have to do is if I have to instantiate a variable, all I do is x equal to 1. And so in this language, there is no semicolon. Semicolons are optional. Parenthesis is optional. So I do not have to do println with these parentheses. It's just that as if you just write English, you just type it in without the parentheses. And and then there is list, like in Java. All you have to do for a list is that, and then iteration over the list is very easy. In here, you don't have to do for, in, and all that stuff. All you have to do is list.each, and then this is a closure. We'll get to that later. And then so I could do just that. And it is an implicit param, which takes into account each of the elements that we iterate through the list. So I could even do something like item, and then do that. I'm explicitly giving it a name within that closure, but then I don't have to do that because it's implicitly provided for me, and I could use that. And with Groovy, the equals is a little different. In Java, when you do A equal to B, then it's just matching the addresses, the reference of the elements. In here, what it is called Groovy truth, wherein if I said there is a list 2, which I'm cloning out of list 1, and then if I want to say if list equal to list 2, then println lists are same. So they are the same because it's doing the dot equals, which is dot equals equivalent in Java. So if I have to just match the addresses, then what I will do is dot is. This is equivalent to equals to in Java. They're not the same because the addresses don't match, it's just the contents that match. And let's see, with clone, you could just, instead of doing list 1 element equal to list 2, instead of iterating through it and copying those elements into another list, you could just do a clone by which it'll just make a copy of it. And
for a complex object, does it do a shallow copy or deep copy?
With maps, I'm not sure. I haven't tested that. I've only tested with not complex maps, just simple maps, and it seems to be doing deep copy. And there is with conciseness with Groovy, what we can do is if I have to, I don't have to do if list is not equal to null and list dot size is greater than 0. We don't have to do all that like we do in Java to see that if the list has in fact some elements. So all I do is if I said list is equal to, if it's an empty list, then the list would be this would turn out to be false because it's an empty list. If it has any elements, then it is true. Else it isn't. We don't have to do a null check on that, and to see that if it has any elements or anything. And the operators that we have are we have a ternary operator wherein we could do let's say def name is equal to Solution Street. Say name is equal to if name, then you do something else, you do nothing. So if I do this, then it's just that this this concise if else block is if name is in fact not null and not empty, then it outputs Solution Street else nothing. But we know that we are doing say if I just had to, if I were doing just name, if it's name, then just print name, then it does just that. But I could just club these two. It minimizes typing when I do this, because in fact, if that is name, if I'm not doing any transformation, then it doesn't make sense for me to repeat that. So I can cut it short and then just do that, and it's called the Elvis operator. Then I'm not repeating whatever I want. And with, say, 5, let me just clean up this. And then you could do many closures on, and many operations on list, like I could say diff find 1 for me equal to list, that's fine. I could just do if ID equal to 1. And so iteration over list and then finding it, transforming it is very easy with Groovy. And then I can also do find all where ID is greater than 2. Then it would return me another list that is with all the items that are greater than 2. And I could even sort this. And, okay, so let me just, so it sorts it. And then if I want to give it a sort behavior wherein it is graded, if I can give it a comparator, then I could say that compare 2 elements, and then if they're equal, then put them next to each other. If one is greater than the other, then it is 0 or -1. And if there's negative numbers in there, then I could just compare the values and then not take the negative into consideration and then just give it sort it in a particular way. Then I could also do names, like and then do sort it because it's strings, it just does string sort. Oh, it's already sorted anyway. Okay. And then it could sort it. I could sort it in a by size, and so then it sorts by the length of the name. And I could also do any that is greater than 3. If any item in that list is greater than 3, it'll return me a true or false. So instead of going through the list and then comparing each of those values and then setting a flag, and then at the end of the iteration using that flag, we could just do this. It's all concise coding. And then if I want to see if every element is greater than 3, because every element is not greater than 3, it returns a value of false. And there is a spread operator that I could use on this list, wherein I could just say Mm, okay. So I could apply that or dot star. So let's Groovy dot star multiply two. That's what I thought I did. Maybe let me try this. Okay. So when I do this, now this is taking that list and then it is making another copy. It is doing twice of what it is doing, but I wanted to just multiply each of those items with one. So let me do this. This is what it does. This is to collect um, operate operator, you could say, that would act on each of those items in the list and then transform it accordingly. And then this could alternatively be done with the spread operator too, which would again go and then apply the same thing across the across the list. I couldn't get that to work, but yeah.
I think you just had a typo, multiple instead of,
Really?
yeah, list asterisk,
Okay.
yeah.
Let me. So I did multiply. That's B2. Okay. Yeah. Thank you. And so we instantiate a new list by doing this, and then we could do a push into this list using a left shift by doing this too, and it is simple and easy. And then we could do dot get at a certain index, like get 0 would give you number 2, and get 1 would give you number 3. And then we could do dot remove, and then give the index of the element which you want to remove. And there's many other operations that you could do, and then add and add all, dot add, and then one element would add that single element, and then you say dot add all and give it a list, it would add all the elements of that list to the existing list at the very end, and things like that. And for a map, you would do something like, and in here, for arrays are also instantiated with square brackets and not the parentheses, because they are reserved for closures in Groovy. So we don't do that. And then a map could be instantiated like that because it's a key value pair. And So I could say map, let's see, so I could say, and then because these keys are recognized as, these are keys for a map, they don't have to be enclosed within single codes. They are just, it's implicit that they are surrounded by single codes. And something like that. Oh, I don't. And if you give single codes, it'll take single codes too. And then I could just say that, or I could do this too to get that. And then if I want to add something else, all I'll do is and then say if I have to perform this operation, the assignment operation on this, and do,
So that syntax is for I'm really,
what's that?
that syntax is map dot itself,
Uh-huh.
is to add to the list,
Add to the map, yes.
to the map.
So it's just like it's an object, and then you're adding properties onto that. And then if I have to do that many, many times, then all I have to do is do that, and then say that equal to Florida, and because again, iterate through the map, just like map.each, and then have a closure there, and then use the implicit param there that it gives, which would be each element, and then I could do I could do print, then that would print Virginia and each of those in set lines. And if I have to do I can do it that way. So, and again, there is another one which is you can iterate with index, wherein the index is also provided for me, and I could do ID and then index. So this one, it separates the params that we use here with the rest of the closure body. And so the index is zero-based, so we need to add 1 if you want to display it correctly.
What if you print for an element?
What's that?
What if you print for an element? What would be the output?
It would say it's not there.
It doesn't throw any exception or something like that.
I don't think it throws an exception for that. So let's say we do no. And then, so we've dealt with lists, and then there is something called cores. Is if I say this is integer 1, and then if I have to print this as a string, then all I do is core this as x as string. So if I do string instance of string. So you could just, with the keyword as, you could transform a variable of one type to another type, as long as that's valid. So if I do integer, say if I say string equal to a blank string, and then do that variable as integer, then it won't be able to transform an empty string into an integer. So then we would get a number format exception. But then as long as it is able to do the transformation, it will.
Where was X defined?
X is defined as something above. X is 1, something, yeah.
That's what it is.
Yeah.
And then, so with Groovy, you don't have to define it, you don't have to type it. If you don't...
Yeah, yeah, it would just be an object.
It figures out.
Yeah, it figures out at runtime.
Okay, but if you do type it,
Yeah, it'll take it.
What's the advantage?
So, the advantage is that it doesn't have to, you won't run into runtime errors.
Right.
So you would know that at compile time it would be caught. So this is expecting, say, if you have a method that is expecting an integer, and then you give it a string or something, then it'll complain. But otherwise, if you just gave it a typeless variable, then it would compile at the time when you're compiling it. You say it is expecting an integer, but then you give it a string, then that would fail when you're running it.
So that actually brings me to my next question. So Groovy has to be compiled?
Yeah, it
It's
compiles to
not interpreted?
bytecode. Yeah, it's interpreted here, but then when you package it and all that, it compiles to bytecode, and then it could be run on JVM. It is a script. It's just like Perl, wherein you don't have to compile it and then run it. It just is interpreted.
So is there similar to Ruby, is there a console?
Yeah, there is a Groovy console.
Okay,
yeah, I have it. You just could test your code on the console by just writing your code and then running it. You don't have to have a class with a main and all that.
Okay. And then if you were going to add methods to this class,
it would just be so and then something like that. And
well,
then
that's within the main, right? So you would have
Yeah.
it outside the main.
yeah, outside the main, sorry. And then with Groovy, there is no return statement. So whatever is the last statement in the method, that whatever expression it computes it to, that is what is returned. You don't have to explicitly say return this value. So I have maybe it takes in A and B, and then I'll do A plus B. I don't have to say return here. It automatically just returns that whatever is computed in the last line of the method.
And to use Groovy, so you have to package Groovy as an import. Oh no, that was package. Was that import Groovy up above the test class?
There's nothing there.
Scroll up
There is a package name.
Oh, it's just a package my Groovy.
Yeah.
Okay. So in order to use Groovy, you just need the Groovy library to.
Yes. And then by default, we would get all the Java IO, Java Lang, Java util, and all that into Groovy. So you don't have to explicitly go say import Java util date or Java SQL, something like that. You don't have to do that. It's readily available. And then with Groovy, Unlike in Java, where you have, say, Java util date and Java SQL date, then you would import one, and then you will have to explicitly write the whole package name, then you are using that, the other date in the program. But here, what we could use is use an alias, as an import some class as, give it a name, your own name, and then use your own name within that program, within that Groovy class.
And then are there packages, are there libraries for Groovy that you would import, that you would need?
Yeah, there are.
External?
Yeah, any external libraries that we do for either Excel, exporting Excel, the model, the view that we use to do that, and then some of the classes, any classes that we use. And, yeah. And I guess I've covered Groovy, yeah, on a very basic level. And then, of course, we can do anonymous classes, inner classes, interfaces, just like how we do in Java. And then there's design patterns too. And if we, yeah, we can move on to Grails now.
What is the whole objective of having this language? Like, this is the exact kind of.
So it's concise. It's concise. It has powerful features, unlike in Java, and then you get Java with it, all the goodness of Java, and you can write concise code. And then with Groovy and with Grails, you can build applications faster because you don't have a lot of architecture behind it. It's a Grails application would be a simple MVC pattern, so where you have the model, view, and controller. So controllers, they do the routing, and then they grab the model, and then they give the view to the user. And then, of course, because you want to separate the business logic, you don't put everything into the controller. You have a separate service layer, but then this is all you need. So you have a service layer, and then controller, model, and view. It's simple, faster building of applications. And so let's go ahead and create, and then because this is an Eclipse-based IDE for Groovy Grails, so when I create a Grails project right here, it creates everything for my project. And then it comes with an embedded database here, which is an H2 database. I could use that. It is an in-memory database. And here is the structure. The project structure is domain is where you put all your domain classes, and controllers are, again, self-explanatory. Views is where your GSPs are. GSPs are Groovy server pages. It is a technology by which Grails manages the view for the project,
Similar
the application, similar to JSP.
Yeah.
And then you put your services in here. Tag library is where you use, just like the JSP tags, we have GSP tags, the G tags too. So those are all available by default, but if you have any custom tag libraries that you want to build, you can build them and put them in there. And this conf folder is where you define your configuration, your data source, and then Bootstrap Groovy is you can do, when the application initializes, you can do something here, as in you can create your data here, so that every time you kill your server and then bring it back up, your data is not erased. And yeah, you could also package Java libraries into this, into a Groovy, into a Grails project, and then you could use classes in there, and then there's Grails plugins that you can use. And the web app has JavaScript and all that you can include. That's the structure. And then let's go ahead and create a controller. So this is the controller, and then let me quickly run this project. So a Grails project could be run on any server that can run a Java project, like Tomcat, JBoss, and in here, there is a built-in Tomcat that is available. So I'm running the project within the IDE. So what you do is Grails run app. If you were doing this on command line, then Grails run app is what you would run on the project directory. So, um, so the server is ready at localhost 8080. And then hello is my controller. So I just use hello, the word before controller, and then I do that. Okay. And then what I do is, so by default, when I do hello here, it tries to run the index method. So you don't have to actually specify the index method here. So if you have, it by default goes and tries to run the index method there. So in the index method there was nothing. It was an empty method. So it didn't know where to go. So, and it was trying to look for index.jsp by default, and it wasn't there. So it's complaining. So now that I have something here, so if I run this again, so it just displays whatever I have it there. But then we cannot always go and then type all that we want here. We cannot type in all our HTML here. So that's the reason we have GSPs. I can do something like there is. And then if I have to, in views, I go and then I add a new GSP there. And here I go. Okay, if I do that now, it says hello. So it doesn't, I mean, it is conventional configuration, so we don't have to configure where my GSP file is, where my, what my methods in the controller are. So if I declare my controller and have an index, even without having an index there, if I have my index.jsp in the correct folder, then when I say hello, when I'm passing my request to that controller, it automatically invokes the index method, which I did not write, but then by default it does that, and then goes and picks that index.jsp if I have it in the correct folder. If I don't have it, then I have to mention my view here. I could just do hello and then do a test folder there, and then move my index folder there. Then if I do that, I'll have to explicitly mention my view there. And then as to what to display there, I could just say, and I could give my model here, which would be the list. And here on my index, I could say Mm, okay. Yeah. That would be the list, and so I am giving it the list, and it has to display the list in there. Oh, that has to be model. Okay, model. I have to send it a list, a map. Okay. So it displays all of them. So model, so view is the GSP, and then model is again a map of all the data that I want displayed on the view. So and then domain is where I would go and declare all my domain objects, and then Grails uses GORM, which is Grails Object Relational Mapping, which makes it easier to do all the database persistence actions. So I'll go ahead and maybe make a class, a domain class, which is so in here, all I simply do is and in here, I'll do so with classes, we can instantiate a class by saying an object by saying new person, and then I could say person dot first name is that, and person dot last name is that, and pass that person in here. And I could use that. Instead of doing that, I could instantiate that person with arguments in parentheses. It would be the same. So we don't have to construct, have to have constructors and getters and setters like in Java. If there's no getters and setters, then we cannot access those, and if we declare them private, then we cannot access them like we can access a public variable. So in here, we don't have to write constructors. We could just instantiate an object by passing in values into those parentheses, and then also just do dot first name, dot last name, and then have variables. And
But you didn't define anywhere person class, right?
new person.
The class,
The class.
The class is right here,
Oh,
person
yeah.
or Groovy.
Oh.
And then, so there is Grails. Now, this comes with a feature which is called scaffolding. Scaffolding is nothing but it would give us building blocks so that we could go and do CRUD operations. So right out of the box. I mean, until of course, we don't want to use CRUD operations that just come right out of the box because we will have our own customizations to be made. So I'll just give you one quick example at scaffolding and how we do scaffolding with Grails, and after that we'll go off and then just do a display of the form and then saving of data. So let me create another controller here, and with Grails, so all I do is for scaffolding to take effect, I just do scaffold. Do that, and then we have the person class available anyway. Okay, let me just stop this. Then with this scaffolding, what you can do is you could just go to that controller and then have a list of people, persons displayed, and then you can do create, update, delete, etc. So right now there's no people there, so I could just go and add a person. And then it creates one person. If you go to the person list, you will see that there is one person there. And then I could go and edit this. And then the person is that. I could just go delete him and add a new person. Okay. That's it? Or
I can do that.
okay.
Different person today.
So we could do this, but then not all the time. It would be such a vanilla case wherein we would have just the names and then you give it the data and then try creating, deleting, and all that stuff. So our real life cases would be much more complex than that. So let's go, instead of doing the scaffolding, let's go and do display. And I would go say define person or new person, and then do add person. And then one would be so we'll go make another view, folder, and then add person. Folder name. Person already exists. Okay, because when I created the person controller, it already created that folder for me. So let's go and add the index. Make a copy and then put it there. Let's modify that as add person. And in here, what we could do is do a form, and we could use, and if this, form has been displayed by a controller, you don't have to mention what, controller it has to go to. It would by default go to the same controller unless it's a different one, and then you'll have to mention controller equal to, if it's a different controller that is handling the action. And okay, if the add person GSP looks like this. Okay, we have that, and then let's define the save. So here we don't have to, for every code change that we do, we don't have to stop, compile, and then run the server again. So action, save, controller. Did I give the controller? Okay. So first name, last name, and then save. So in here, this is the text field. The name is first name, and then the name is last name for these two text fields, respectively. So when they go back, when I click save, the params that these two values would go back as are first name and last name. So if I change this to just F name and L name, then that's how it'll go back to the controller as. So when on save, here what I'm doing is these are the params. You don't have to declare them as params in the method signature. It just is implicit that anything that comes to that method is in params. So params.firstName would have whatever value you've given for first name and last name for last name. And then when you're doing that, because just like before when I said first name was Arthur and last name was Frankel, it would translate those and into the first name and last name of that person object, and it would create the object. And p.save, because we are using the in-memory database, it would just go and save it to that database. So here, and I do save. Here, there's an out pointer exception.
What were the, in the person object? Because the person object is the capital L, does it match up the actual name?
Yeah.
Oh, that's lowercase L.
Yeah, the lowercase
Person
L.
Groovy, those were the attributes in the person.groovy class?
Person.groovy class, yes, first name and last name. So we have the person controller there, and we have the save method. We are taking in.
And you didn't create the display person GSP? Rendered the view? And then
Yeah,
after you're
the
done with
display
the
person,
save,
yes.
you didn't create that, right?
Add person. Wait.
Works for me.
Yeah.
Doesn't work for others.
So because we have the domain object there, and then, because GORM is running behind the scenes, we could do p.save. Now, next, what I could do is p equal to person.get. I could do a get on the ID, or if I know the first name, so get by, first name, and then I could give Diane's name. And then when I have that person, I could do p.delete. And so this is something that is given to us by GORM. And then there is criteria API that is also that also comes with GORM, wherein we could just mention criteria on a person. There, the criteria could be the last name is something, or the first name is something, and the age is about 30 or something, and then we could query on that. And then there is other SQL, which is the Hibernate SQL, wherein sometimes the SQL is so complicated that we need to write them. So then we could select something from this table, join with something else on some condition, and then get results back. So because we're running short on time, I cannot take you through head SQL and the criteria API. So, and then we could, because we don't want controller to be doing all this stuff, we could just put all this logic into services. So that would be, again, there would be a person service.groovy, and then we could write all this there, and all it does is it calls the service to execute all this logic and any additional business logic. And all it does is handles the request, does the routing, and then shows data to the view.
And similarly with Grails, you have a console that you could run.
We could do it on command line too.
Command line, right.
Yeah, and then
I think in Eclipse, I think one of those buttons starts a console, starts a.
I've only recently started using Groovy Grails tool suite.
Okay.
I was using NetBeans before, so I haven't explored everything that this gives.
So how do you like Groovy on Grails versus traditional Java or anything else you use?
It is simpler and faster. I mean, there are some things that you cannot do, in the sense that more security, or if there's annotations wherein you could block people from accessing certain pages if you want to and all that, and it comes right out of the box, and then you could write your custom classes, custom security utils, and then have those annotations applied on your controllers and all that stuff. It's less complex, faster learning curve, and you could do much of everything else that you can do with other projects, like a traditional Java project. Yeah, I would say.
Any questions on the call?